Before the break, we were looking at chromosome mutations. What can happen when meiosis is faulty and chromosomes become reorganized? Pieces can break off, they can swap around, they can become inverted. Parts of one chromosome can attach to another chromosome, and at the cellular level or the biochemical level, we can understand these are the faults. But what are the consequences of those faults? So let's focus on one of these consequences in particular. In anaphase 1, we know that the chromosomes go to the different poles. The homologous pairs go to the different poles. Now, what happens if this chromosome didn't go to its pole? What happens if it, instead of going to the top pole, it went to the bottom pole, or it stayed with its homologous pair at the bottom pole? What you'd have then is one chromosome going to the top pole and 3 chromosomes coming down to the bottom pole, and we call that non-disjunction. Non-disjunction means that it's not simply a case of both homologs going to the top pole and 2 homologs coming to the bottom pole. 3 would come to one pole and 1 would go to the other pole. And you can see that that is going to result in a gamete that is missing a chromosome, or a gamete that has too many of a particular kind of or number of chromosomes. And one consequence, or one known example of a mutation that is brought about by a non-disjunction, is Down syndrome, or trisomy 21. And a person with trisomy 21, or a person who has Down syndrome, will have 3 copies, that's where the name comes from, trisomy, 3 copies of chromosome number 21. This picture is something that you will often see in an example, or in an exam or in a test, often coming up in your matric exam. This is called a karyotype. What it is a picture showing all the chromosomes of that particular species. So you can have a karyotype of mouse chromosomes, or a karyotype of a particular plant's chromosomes. This karyotype that you are looking at is a human karyotype, and it's a karyotype of a person who has Down syndrome, or trisomy 21. And you can see that each of the chromosomes is organized with its homologous pair. What happens is scientists can take a photograph down an electron microscope of all the chromosomes. And as they are possibly around about the beginning of metaphase 1, when everything is out at the pole, at the equator, so that a nice flat photograph can be taken. Then they take the photograph and they cut up the individual chromosomes and they replace them and match the homologs together. And you get this. So this is an artificial construction. It doesn't look anything like as nice and neat as this in your cells. This is constructed by scientists from photographs, and they can match the 2 copies, or the copy of chromosome 1, the 2 of chromosome 2, and so on. And you can see that in this particular individual, there are 3 copies of chromosome 21, and that is a result of a non-disjunction. During anaphase 1, instead of chromosome 21 splitting and going 1 to the one pole, 1 to the other pole, both of chromosome 21 went to one pole. The other gamete that was produced had no chromosome 21, and what would probably have happened is, if that cell had have been fertilized, it would have been aborted fairly early. It wouldn't have survived very long. But the other, as chance may have, and it's completely random, the gamete that had 3 of these copies of 21 can survive, and the offspring would then have Down syndrome. Can you tell if this is a karyotype of a male or a female? Right, this is actually a karyotype of a male, because if you have a look and find the XY chromosome, you see that it's an X chromosome, it's a Y chromosome, which means that it's a male. If it was female, it would have XX. So this little boy who has Down syndrome, what would be the characteristics or the consequences? What would this child be like? Well, he may have varying degrees of mental retardation. He may not have the same cognitive abilities. He could have poor muscle tone. He might not be able to cope with ball games, possibly as you would. He may have a tendency to heart conditions as well as a very particular physical appearance. This little boy looks a very happy chap, and lots of parents of Down syndrome children will tell you that their children are very loving and very happy, and they have a very positive and very sensitive approach and outlook to other people. They have smaller eyes. Their ears may be situated slightly lower than normal, a flatter forehead, large tongue, short stubby fingers and toes. But I think what is very important is what's inside the person rather than what they look like. Science shows us that the age of the mother does have something to do with the incidence of Down syndrome or trisomy 21, and that certainly in older mothers there's a greater tendency towards producing a child that has Down syndrome, and so it suggests that meiosis could become more faulty as the organism increases in age. What we've been looking at today is what happens when cell division goes wrong. What happens with faulty mitosis? Cancer. And what happens with faulty meiosis? You've seen that there's a range of mutations that some can have small consequences, some can have huge consequences. I hope to see you again next week, where we continue looking at the various aspects of DNA in your cell, and we're going to be moving on to genetics. So I'll see you next week.